the smartest AI in the world, and we're going to show you exactly how and why. It really is remarkable to see the advancement of artificial intelligence.
Recently, scientists at MIT asked Grok AI to contend the Fermi paradox, the question that has haunted space science for decades. In a universe this vast, why has no confirmed signal from another civilization ever reached Earth? At first, it sounded purely academic, but the researchers wanted to see how an advanced AI, built on an enormous library of human knowledge, would interpret the possibility of extraterrestrial life. But when Grok's response was shared with people in the SETI and astrobiology world, the mood shifted fast. The reaction was not excitement. It was closer to a silent alarm. So, what did Grok reveal? Where is everybody? Long before Grok AI could answer anything, Enrico Fermi, one of the sharpest minds of the 20th century, asked the same question in the simplest way possible. It happened in 1950 at Los Alamos, New Mexico. Enrico Fermi was not some random dreamer staring at the stars. He was a Nobel Prize-winning physicist, one of the people tied to the birth of the nuclear age. During a lunch conversation with other scientists, the talk turned to alien life, space travel, and the size of the galaxy. Then Fermi cut through all of it with a question that still hangs over science like an open door. Where is everybody? That is the heart of the Fermi paradox. It is not just asking whether aliens exist. That question is too simple. The deeper question is far more uncomfortable. If space is so massive, if stars and planets are so common, and if the universe has been around for so long, why is there no obvious sign of anyone else? No confirmed message, no confirmed visit, no clear probe, no object in the sky that every scientist can point to and say, yes, that came from another civilization. The more we learn about space, the stranger that silence becomes. The observable universe has been estimated to hold roughly 2 trillion galaxies. Not stars, galaxies. Each one can hold billions of stars of its own. Our own Milky Way is only one galaxy, and even that is almost too large to feel real. It is about 100,000 light years wide, with around 100 billion stars spread across its great disk. And those stars are not sitting alone. The Milky Way contains at least 100 billion planets. That means planets are not rare prizes scattered through space. They are everywhere. Some are huge gas worlds. Some are frozen. Some are burning hot. Some are rocky. Some move around stars, much like our sun. Over time, telescopes have confirmed more than 6,000 planets outside our solar system. And that number keeps growing as more worlds are checked and added. So, we are no longer guessing whether planets are common. We know they are. That makes Earth feel less like the only stage in the theater and more like one seat in a packed stadium. The hard part is that a stadium that packed should not feel this quiet. Then comes the next pressure point. Some planets are in what scientists call the habitable zone. That simply means they orbit at a distance where liquid water could exist on the surface if the planet has the right air, pressure, and conditions. It does not mean the planet has life. It does not even mean the planet is friendly. It only means it sits in a place where one key ingredient for life may be possible. Still, the numbers are hard to ignore. A major study using Kepler telescope data estimated that about 22% of Sun-like stars may have an Earth-sized planet there. Even if most of those worlds are dead, dry, frozen, poisoned, or unlucky, the number of possible stages is enormous. The universe seems to offer chance after chance after chance. And yet, nobody has stepped onto ours. Time makes the whole mystery even heavier. The universe is about 13.8 billion years old. Our solar system formed about 4.6 billion years ago. That means stars were burning, planets were forming, and possible worlds were circling other suns billions of years before Earth even existed. A civilization that began only a few million years before us would already be far ahead. A civilization that began a billion years before us might be so advanced that comparing it to humanity would feel like comparing a jet plane to a campfire. If even one world got that kind of head start, the silence becomes harder to brush away. Maybe they would have sent a message. Maybe they would have spread. Maybe they would have left something behind. Maybe there would be some clear mark in the sky, some sign that intelligence had already crossed the dark between the stars. But so far, there is nothing confirmed. More than 6 decades of searching for signs of intelligent life beyond Earth have not produced a signal the world can accept as real. There have been strange signals that made people look twice, but no confirmed alien message has survived the hard checks needed to turn wonder into proof. But before we assume nobody is out there, there is a much simpler problem. We have barely searched at all. The tiny search inside an almost endless galaxy. The first serious attempt to listen for aliens was not some giant sweep of the whole sky. It was much smaller. In 1960, astronomer Frank Drake began Project Ozma at the National Radio Astronomy Observatory in Green Bank, West Virginia. He used a radio telescope to listen to 2 nearby stars, Tau Ceti and Epsilon Eridani. Both were about 11 light-years away, close enough to feel like sensible first targets, but still so far that even light itself needed 11 years to cross the gap. Drake was not checking every star. He was not listening to the whole galaxy. He was not scanning every possible signal aliens might use. The first real modern attempt to hear another civilization was more like pointing an ear at 2 nearby doors and hoping someone knocked. Nothing clear came back. That failure did not end the search. It gave the search its shape. Scientists focused on radio waves because radio waves can travel across huge distances in space. A strong radio signal can cross the dark between stars better than many other kinds of signals. Even better, a very narrow radio signal can look unusual because nature does not usually make a perfectly clean radio tone in the same way a machine can. So early searchers picked what seemed like a smart place to listen. Hydrogen is the most common element in the universe. Because of that, some scientists thought another smart civilization might also choose a radio spot linked to hydrogen, almost like a shared meeting place in the sky. It was like choosing the most obvious radio station in the universe and waiting for someone else to tune in. But waiting is harder than it sounds. Searching for alien signals is not like turning on one radio and hearing every station at once. It is more like trying to guess the station, the language, the time, the strength, the direction, and even the kind of tool being used. The sender might not be using the same method, the signal might be too weak. It might pass by while the telescope is looking somewhere else. It might be buried under noise. It might never repeat. That is why the Great Silence is not as simple as it sounds. We have searched, but we have not searched everything. We have pointed powerful tools at parts of the sky, across certain ranges, at certain times, looking for certain kinds of signals. That is very different from checking the whole galaxy, every second, in every possible way. Decades after Project Ozma, the search became much bigger. In 2015, Yuri Milner and Stephen Hawking announced Breakthrough Listen, a $100 million effort to search for signs of intelligent life. It gave scientists access to major telescope time, huge stores of data, and a much wider plan than earlier searches could manage. That sounds enormous. And compared with the early days, it is. But even Breakthrough Listen does not mean the sky has been fully checked. It is not the whole sky, all the time, at every signal type. It is a far stronger search, but still a search through a space so large that even our best efforts feel small. And then there are the false alarms. In 1977, a powerful radio signal was detected by the Big Ear Radio Telescope in Ohio. It became famous as the wow signal because the astronomer who saw the printout circled the strange reading and wrote wow beside it. For a moment, it looked like the kind of thing people had been waiting for. But the signal never came back. That is the problem. One strange signal is not enough. A true discovery has to return. Other observatories have to check it. Other scientists have to test it. The signal has to survive every boring, careful question before it can become the biggest discovery in human history. This is where the search becomes even messier. Earth is full of its own radio noise. Satellites, aircraft, phones, electronics, radar, and equipment can all create signals that confuse the search. A telescope may catch something strange, but strange does not automatically mean alien. Sometimes it means a machine on Earth is leaking noise into the data. Scientists have to clean that noise out before they can trust what is left. In recent years, researchers have worked on better ways to tell whether a signal truly came from deep space or from something much closer to home. And even if someone out there wanted to hear us, there is another brutal problem. Earth only became loud a moment ago. Earth has barely announced itself. For almost all of Earth's history, our planet did not sound like a technological world. Life has been here for a long time. Oceans formed, animals rose and vanished, and humans appeared near the end. But for most of that long stretch, Earth gave off no clear sign that anyone here could build machines, send signals, or ask questions about the stars. Only in the last century or so did humanity begin filling the air with strong radio technology. To us, that feels like a long time. Television arrived, satellites went up, phones moved from walls to pockets. But in the life of the galaxy, a century is almost nothing. Radio signals move at the speed of light, but space turns even light into a slow traveler. If a signal left Earth 100 years ago, it has only moved about 100 light years away. That may sound huge, but the Milky Way is about 100,000 light years wide. So our strongest modern hello has crossed only a tiny patch around our own star. On a map of the Milky Way, our radio bubble is not a shout across the galaxy. It is a small breath around one star. That changes the whole question. When people ask why aliens have not contacted us, they often act as if all of space has already heard Earth and chosen not to answer. But most of the galaxy would not even know modern humanity exists. Our signals have not had time to reach them. To most stars, Earth is still just another small world circling quietly in the dark. Even nearby contact would be painfully slow. If a civilization 50 light years away noticed one of our signals and answered right away, the full back and forth would still take 100 years. One message goes out for 50 years. One reply comes back for 50 more. By the time the answer arrived, the senders might be gone. If a civilization was 1,000 light years away, one question and one answer would take 2,000 years. Across bigger distances, a reply could arrive after languages have changed. Borders have vanished, and the world that asked the question no longer looks the same. Contact is not a phone call. It may be a message sent by grandparents and answered by descendants. There is also another problem. Earth may seem loud to us because we live inside the noise. We are surrounded by phones, towers, satellites, screens, radios, and machines. But from another star, much of that noise fades fast. Not every signal blasts out evenly in every direction. Many modern systems are weak or built to keep their energy close to Earth. A lot of our communication now moves through fiber cables, undersea lines, and narrow beams aimed at receivers. Even the signals that leak away can be thin, patchy, and easy to miss. A study of Earth's mobile phone tower leakage found that those signals are not steady beacons shining in all directions. They change with direction and timing. Even a nearby civilization within 10 light years, using tools as sensitive as the Green Bank telescope, would not currently detect that kind of leakage from Earth. So, Earth is not the bright radio lighthouse people sometimes imagine. Powerful radar is different. Radar transmissions meant to study planets and objects in space can be much stronger than normal broadcasts. The former Arecibo Observatory in Puerto Rico sent famous signals from humanity. In 1974, it sent the Arecibo message, a short burst aimed toward a distant star cluster called Messier 13. That message has been traveling for about 50 years. It has crossed only about 50 light years. Its target is around 25,000 light years away, so the message is still at the beginning of its trip. Even if someone there could receive it, the answer would not come back for tens of thousands of years. So, aliens may not be ignoring us. They may not have heard us. Or their answer may already be moving through space, still thousands of years away. But distance is only half the problem. The deeper problem is that an advanced civilization may not communicate in any way we expect. The message might not look like a message. Humans keep waiting for aliens to act like humans. We expect a message, a signal, a ship, a face, or some clear hello from across the dark. We expect contact to feel like contact. Something aimed at us, something made for us, something we can notice, read, and answer. But a civilization far older than ours may not care about saying hello. It may not think of contact the way we do. It may not need a conversation. It may not even use the kind of tools we keep watching for. We keep waiting for a knock on the door. But advanced life may leave fingerprints, not greetings. That is why the search for life has grown wider than simple messages. Scientists look for two broad kinds of clues. One is a biosignature. That means a sign that life may exist, or may have existed before. It could be a fossil, a certain chemical, or a pattern in a planet's air that living things might create. The other is a technosignature. That means a sign that technology may exist, or may have existed before. It could be a radio signal, a laser flash, extra heat, strange pollution, a huge structure, or something else that looks hard to explain without tools. That shift changes the whole question. Scientists are no longer only asking, did someone send a message? They are also asking, did someone change their world in a way we can see? A message is not the only thing a civilization can leave behind. On Earth, cities glow at night, factories change the air, machines give off heat, satellites move above us, roads cut through land, dams reshape rivers. Even if humans never sent a greeting into space, our technology would still leave marks on our planet. So if another world had a civilization, the best clue might not be a voice, it might be a trace. One of the boldest ideas came from physicist Freeman Dyson. He suggested that a very advanced civilization might try to collect huge amounts of energy from its star. People often call this idea a Dyson sphere, but it does not have to be a solid shell like something from a movie. It could be a wide swarm of structures moving around a star, collecting starlight like countless solar panels. If a civilization used its star like a giant power plant, some heat should leak out. That waste heat might glow in a way telescopes could notice. Another useful idea is the Kardashev scale, created by Nikolai Kardashev in 1964. It ranks civilizations by how much energy they can use. A Type 1 civilization uses energy on the scale of its planet. A Type 2 civilization uses energy on the scale of its star. A Type 3 civilization uses energy on the scale of its galaxy. Humanity has not even reached Type 1. We are still learning how to handle our own planet's energy. But if another civilization reached Type 2, it might leave a mark around its star. If it reached Type 3, its activity could change parts of its galaxy. The bigger the civilization, the harder it may be to hide its energy bill. The same idea can apply to a planet's air. A world with industry might carry strange chemicals in its atmosphere. Some could come from pollution. Some could come from artificial gases. Some might be linked to large-scale energy use. A telescope might not see the buildings, but it could see the chemical shadow those buildings leave behind. There is also the probe idea. An advanced civilization might not send a broadcast across space at all. It might send machines. A probe can wait. It can observe. It can stay near a star or planet for a long time. It can send a signal only when there is something worth sending. No confirmed alien probe has ever been found. But there is another answer to the silence, and it is darker. Maybe advanced civilizations do not speak because speaking is dangerous. The dark answers nobody likes. So far, the silence can be explained in ways that do not feel too frightening. Space is huge, messages take time, our search is small, Earth has only been loud for a short while. But there are darker answers. Maybe nobody has contacted us because almost nobody makes it far enough to try. Life may be common, but complex life may be rare. A planet can sit in the right place around its star and be lifeless. It can have water and still have nothing swimming in it. It can have simple life and still never grow anything that builds tools, lights fires, or turns metal into machines. A world may need a long-lasting star, a rocky surface, liquid water, a protective atmosphere, a steady climate, the right chemistry, and enough calm time for life to grow complex. Miss one piece and the story may end before it begins. A planet can be wet and still be dead. A planet can be alive and never build a radio. Then comes the Great Filter, one of the coldest ideas in the alien silence problem. Robin Hanson used the idea to describe a possible barrier between dead matter and a civilization that spreads beyond its own world. Somewhere along that path, there may be one step that almost nobody passes. The frightening question is where that barrier sits. If the filter is behind us, maybe Earth has already passed the hardest part. Maybe the birth of life is nearly impossible. Maybe complex cells are rare. Maybe intelligence almost never appears. Maybe technology is the strange accident, not the normal ending. That would make humanity lucky. But if the filter is ahead of us, the meaning changes completely. It would mean many worlds may reach intelligence, build machines, gain dangerous power, and then fail before they spread. Nuclear weapons showed that one species could become a danger to itself. Climate breakdown shows that slow damage can be just as serious as sudden destruction. Engineered disease raises fears that life itself could be turned into a weapon. Self-replicating machines, if ever built badly, could become hard to control. Poorly controlled artificial intelligence raises another question. Can a species build a mind stronger than itself and still stay in charge? Grok can answer a question about aliens, but AI itself belongs to the same strange class of tools that makes people nervous about the future. That may be one reason the sky feels so quiet. Not because the universe hates life, but because life may keep reaching a dangerous stage and breaking itself there. Then there is the dark forest idea. It became famous through Liu Cixin's novel, but the fear behind it is older than one book. If civilizations cannot know whether strangers are peaceful or dangerous, silence may be safer than contact. A message does not only say hello, it also says, here we are. If another civilization hears that, we cannot know what it thinks. Maybe it is friendly, maybe it is curious, maybe it is afraid. Maybe it decides that any unknown civilization could become a threat later. In that kind of universe, staying quiet becomes a survival habit. Another idea is less violent, but still unsettling. It is called the zoo hypothesis. John Ball proposed it in 1973 as a possible answer to the same silence. The idea is that advanced civilizations might know about younger worlds like Earth, but choose not to reveal themselves. They might avoid contact because they do not want to change a young civilization's natural path. They might see Earth the way humans watch wildlife from a distance, step too close, and the thing being watched changes because of the watcher. That raises the question of whether humanity should speak louder. Some people support active SETI, also called messaging extraterrestrial intelligence. Instead of only listening, it means sending deliberate messages toward space. Some say speaking is natural. We are curious. We want to know if anyone is out there. Others argue that no small group has the right to announce Earth to unknown listeners without the whole world agreeing. We already leak some signals, but deliberate messages can be stronger and clearer. Stephen Hawking warned that contact with a far more advanced civilization could be dangerous. Others disagree and say fear should not freeze the search. And that brings the story back to AI, not because Grok solved the mystery, but because machines may change how we search for the answer. Searching the silence with AI. AI is starting to help astronomers dig through data that no human team could ever check by hand. In 2023, researchers used a deep learning system to search breakthrough listen data from 820 nearby stars and more than 480 hours of listening with the Green Bank telescope. Inside that mountain of radio noise, the system found 8 signals of interest that earlier methods had missed. When scientists looked again, the signals did not show up a second time. Without that return, they could not become confirmed signs of alien technology. AI did not find aliens, but it found needles humans had missed in a mountain of noise. That matters because the search for life is drowning in data. Stars flicker, signals fade in and out. Planets pass in front of their suns and leave tiny dips in light. Most clues are weak, messy, and easy to miss. Human eyes are not built to stare at endless streams of star data forever. Machines can help. AI can sort noise from possible signals. It can flag strange patterns. It can search old data again with new methods. It can point scientists toward targets that deserve a closer look. The same change is happening in the search for planets. Before anyone can find alien technology, scientists first need to know where the worlds are. In January 2026, a new deep learning algorithm found 7,000 test targets that may be exoplanet candidates. Another recent machine learning search found more than 10,000 possible planets hidden in test data. Some candidates may turn out not to be planets at all, but each strong candidate gives astronomers another place to check. another world to measure, another possible home for life or technology. AI is helping build the map, and that map is about to grow. The Nancy Grace Roman Space Telescope is aimed for launch as early as September 2026. Roman will study dark energy, exoplanets, and deep space. It will reveal more places where answers could hide. The Habitable Worlds Observatory is even more direct. It is being designed to search for signs of life on planets around other stars. The goal is not just finding planets, but studying their light and looking for clues in their air. Then there is the Vera C. Rubin Observatory in Chile. It released its first images on June 23, 2025. Its camera has more than 3 billion pixels, making it the largest digital camera ever built for astronomy. Rubin will scan the sky again and again, watching for changes other tools might miss. Even Mars reminds us how careful this work has to be. Perseverance found a rock called Chayava Falls in Jezero Crater in July 2024. The rock has features that may be a possible sign of ancient life, but other explanations are still being checked. That caution matters. Even on Mars, right next door, a possible life clue is hard to confirm. A clear sign of an alien civilization around another star would be far harder. Thanks for watching. Now check out the videos popping up on screen for more unbelievable stories.